Hi there, welcome back to the breadboard. In previous videos we've been looking at a number of 3D printers that have been sent to me for review from GearBest. I've had the Trinamics X5S, which is the one right here. We've had the TiVo Black Widow, which is the one right behind me. And we've also, over on my table here, have the HC Maker 7. And all of these have proved to be reasonable printers, I think, for the price. But they all have certain, let's just say, issues that need to be resolved through upgrades and things if you really want to get the best out of them. Now, the Trinamics X5S here, it's a Core XY printer and it runs on 12 volts, so it has a huge difficulty getting its bed much above about 70 degrees, maybe even a little bit less on that one. The TiVo Black Widow here, it can get its bed way above 100 degrees centigrade, so that's not an issue. It runs on a full 24 volts and it uses an external MOSFET for driving the heat bed. The hot end is driven from the MOSFETs that are built onto the board. The HC Maker 7 has a 24 volt system as well, but it too has a little bit of difficulty getting the bed temperatures much above 80 degrees. In fact, you have to wait for a long time and it won't go much above 80. But it is also a 24 volt system. Now, one of the things that has been repeatedly talked about on YouTube recently is fire risks, safety risks, things like that. And a lot of that is because Marlin has not been configured or is up to date, or combination of both. So I did a look at my three printers and discovered that none of them basically are up to date with the version of Marlin. Now, I have to say that my Trinamics X5S, I actually did upgrade it a little while ago from its default stock one, but I didn't really change any of the settings. The TiVo Black Widow is around is version 1.1, I think, 1.1.1 or something. I'll put a chart up. I've actually put it all into an Excel spreadsheet and everything else, so I'll confirm that. And my HC Maker 7, though, is at 1.0.1 or something. It's a really early version of Marlin, and it's a dev version as well. What is common with at least two of these, though, is that the safety features, things like thermal overrun, stuff like that, are turned off. Now, what this means, as Thomas Salanderer, I hope I'm pronouncing that right, Thomas, has said, and numerous other YouTubers, is without these features turned on, if you get a problem with your thermistor or something like that, either a short circuit or an open circuit or something, and it stops reading it properly, the heat could get turned on to the heated bed or the hot end and just stay on, and it'll just ramp up and up and up and potentially either damage the printer or worse, cause a fire and a lot of other damage. So what I want to do is first of all figure out what the controller base type is for each of my printers, verify that I have the pin configurations that are necessary for them, and then I want to first upgrade them all to the latest version of Marlin and then look at adding a few upgrades. I don't want to waste time doing the earlier versions of Marlin. It just doesn't seem to make sense. So what I've done in front of me here is I've ripped out the controller cards from my three 3D printers, and I have them here. I have the Trinamics X5S, the TiVo Black Widow, and the HC Maker 7 board. I've also got some possible upgrade cards here that I will be showing you. Now, in this video, I'm just going to talk about the settings and various other things, and what the options are for doing these upgrades and what these boards can give you. I've got an ST Micro evaluation reference design board, which looks really, really nice, but it may have some issues in connectivity and stuff like that. Well, I'm going to make a separate video for that. We have an MKS base 1.3, which is available through GearBest. And we have a ramps 1.4, which is sitting on top of an Arduino Mega 2560. Now, the ramps 1.4 is basically an 8-bit system. The MKS base 1.3 is a 32-bit with networking, and the ST evaluation reference board is also 32-bit, and it has built-in Wi-Fi. As far as electrically, it's an awesome board. Now, going back to the three that came out of the printer, the Tronxy X5S, it has a board, which is this one. I'm going to put a bigger picture up, which has basically an X, Y, Z, and extruder output. It actually has two connectors for the Z, so you can independently connect both of your Z motors if you want. It only has 3 end-stop connections, which is only for the XYZ minus connections. It has a connector for the display, and it has thermistor connectors for the hot end and the bed. And it has 2 fan outputs, and I think one of those fan outputs may not even be switched. Only one of them I think is switched. It has a MOSFET to drive the hot end and a MOSFET to drive the heated bed. We'll have a closer look when we get to the specifics video for this one. Now, the trouble with this particular board is first of all, the stepper controllers are soldered onto the board. Now, that's not normally an issue. And in this case, it's using, I believe, the A4988 driver chip, but they are soldered on, and the heat sinks are actually glued with epoxy glue, so they won't come off for me to look at what the chips are. Again, it uses a 12-volt power supply. All the hot end and the bed are both geared for 12 volts. Whether it can take 24, I don't think it can. The capacitors, actually the ones I'm looking at look like they're rated for 25 volts. The ones with the steppers are all rated at 25 volts. So if you ran this with a 24 volt system, technically it should take it, but it's getting very, very close to the mark. And there are some other parts like the regulator, to go from 12 volts all the way down to the 3 volts required for the controller on here, or the 5 volts for that. You're going to dissipate a huge amount of heat in the voltage regulator and stuff, because I don't think it's using a switch mode one, not by the look of it. And that's the Tronxy. So you can't add extra things like a BL Touch. There's no pin out for a servo pin to drive it, or if you were going to use an additional inductive sensor or something like that, right? Using the maybe the Z plus pin, which would be the normal default one for bed leveling. It's got really no expansion capability whatsoever. But if you're happy with the way it's working, and you're just maybe doing PLA or something, that's great. So for that one, you'd probably have to upgrade it either to one of the 32-bit controllers, which would be probably pretty good for a Core XY machine because there's a bit more math involved. Or you could simply put in a ramps 1.4 type of board and maybe modify it so that you can have a 24 volt hot end, 24 volt heat bed and potentially hot end, which would involve a very minor modification of the board. The TiVo Black Widow, on the other hand, which is this middle board, is based on the MKS Gen 1.4 board, and it has switching regulators on board, so it can easily handle the 24 volt supply and be able to bring it down to the right voltages for the controller as well as the MOSFETs and stepper drivers and things. Now, the one I have here is using the Texas Instruments DRV8825 controller modules, and it's got 5 of them on here. Now, the problem with those particular drivers is they cause the triggering / salmon scale type artifacts on certain prints. So I will be looking at upgrading this board once we have the latest version of Marlin in it to use the Trinamics drivers. Now, I've got a selection of Trinamics drivers. I've got the 2130s and also the 22 GearBest.h drivers. Anyway, I've got some of the alternates to the Texas Instruments DRV8825 drivers. But the one thing about the MKS Gen 1.4 is it's basically a RAMPS 1.4 compatible. It uses the same pins configuration as a RAMPS 1.4. It's just basically taking the RAMPS, which is a Arduino Mega 2560 with a separate daughter board, which basically expands the I/O for the stepper drivers and the MOSFETs and everything, and they built it all onto one board. It also has some fairly good MOSFETs on here. Now, I've done a separate video on MOSFETs, so go have a look at that if you want to know a bit more about it, but it is pretty good. Now, having said that though, because this is a 24-volt system, and in the TiVo Black Widow they put in a pretty powerful heated bed, they have used an external MOSFET to act as the interface to drive the heated bed, and that's great. Uses standard USB, and as I said, it's using the same Arduino Mega 2560 controller, so it should be relatively easy to upgrade this, and there is an upgrade header for programming right on the board. The last one, which we're going to look at for upgrading, is the HC Maker 7. This is a relatively new company on the block, I think, making this particular 3D printer. And they have a controller board in here, which took me a while to figure out what it was, bit of sleuthing. It labels it as an HJC 2560-C, and I could find no information whatsoever. But I did find references to saying that it works just like the Ultimaker and things like that. So armed with a multimeter and the pins configuration for an Ultimaker, I did trace out some of the connections from the ATmega 2560 to the controllers, the stepper controllers, and verified that the pins are indeed exactly the same as the Ultimaker. This board uses a 24-volt system. It has a switching supply for the control, so it has no issues with heat trying to get the 24 volts down to the 5 volts for the control system. It also has some weird connectors for the hot end. It has a single unified 12-pin connector that drives the thermistor, the extruder, as well as the hot end itself and things like that, all from the one connector. And that's the same for the second extruder output that's on here. The HC Maker is using the 4988 drivers, and I've also noticed that when it's being used, I don't get the same tree ring salmon type skin effects in my prints as I do with the TiVo Black Widow. And the TiVo Black Widow is using the DRV8825s. So whilst the HC Maker doesn't necessarily need to have any upgrades to the stepper drivers, you could also put the Trinamics in there if you wanted to. Now, there's a lot of I/O available on the HC Maker 7 controller board here. We've got Z stops for X, Y, and Z plus and minus. We've got all the connections for the stepper controllers for going out to the stepper motors for X, Y, Z1, Z2. And we have PWM outputs and fan control outputs, as well as a hot bed output driven by a MOSFET that's underneath here. And we have the 24-volt supply coming in. Now, these connectors are not very big, but with 24 volts, normally you don't need as much current because the power is volts times amps. So if you double the volts, you could technically halve the amps and have the same amount of power. So what we need to do with this is we need to look at how we can potentially put some auto bed leveling onto this as well. Now, the nice thing is that it does have some Z plus and Z minus inputs, and normally your limit switch is on the Z minus, and if you put something like a BL Touch, you can, with default with Marlin, it would use the Z plus input for that. Now, the only trick here would be to find out where the servo pins would be for connecting to drive the BL Touch probe in and out. So that's something we would have to look for. Now, there is a little connection up here which might work for that. I'll put some close-ups of all of these boards so that you can see easier. Anyway, those are the 3 boards that we're going to look at upgrading. And as I said, the HC Maker is the one that had the oldest version of Marlin installed. I have now also had sent to me the Marlin source files from HC Maker in China. Now, it's not been published anywhere, so strictly speaking, they're not adhering to the open source guidelines that anybody using Marlin is supposed to adhere to. And I'm in the process of talking to them to try and resolve this, but it's a little bit difficult because obviously there's a language barrier. And one of the things actually that's rather interesting is that I see a lot of people complaining about companies not adhering to standards, not listening to the comments that viewers might make, on my videos or anybody else's videos. And in talking to the folks that make the HC Maker 7, I discovered that they actually don't have access to YouTube because they've got there's this thing called the Great Firewall of China. And I think a lot of the manufacturers in China don't get access to the internet in the way that you and I, or most of us here, are used to. So I actually wanted to send them one of my videos and let them see it on my review for the HC Maker 7, and they couldn't get access to it. So I actually had to put a file on Dropbox and let them get a hold of it that way. Now, what this kind of brought my attention to is the fact that, they're not, it's not that they're necessarily, and I'm not saying that this is in all cases, ignoring our feedback about features, issues, and various other things. It may be simply that they just simply cannot see it. GearBest has access to YouTube and things like that. How they got it, I don't know, but they they have places around the world. But HC Maker and possibly other ones don't. So when we're complaining about things, we need to keep that in mind. And what I'm going to do is I'm going to try and work with the folks at HC Maker to see if I can resolve some of these issues and things and get them to actually publish the files, or let me publish the configurations up on the Marlin website, just so at least the configuration files are there. It is pretty well standard Ultimaker compatible board, that's for sure, so it shouldn't really be an issue. There's nothing on here that I can see that is particularly proprietary. I think out of all these boards, the one thing I really like about this HC Maker one is that they actually have some plug-in fuses on the back of the board for the hot end and heat bed and general board use, instead of having things that are hard soldered in, which makes it, it's a bit of a nice touch. The the MKS Gen 1.4 looks like it's got PCB soldered fuses on there for providing power, but I need to verify that. There are certainly these resettable fuses on the board, which would make it difficult if they ever blew, of course, and then on the Tronxy X5S Melzi board, looking where the fuse is, it looks like it's just simply shorted out with a piece of wire. So there is no fuse in there at all. So that's probably a candidate to upgrade the controller on that completely. I'm not going to go into the other boards right now. What I want to do is go on the computer and go through the configurations that I've discovered for these, and finish off the video basically talking about some of the other potential upgrade, well, not potential, some of the other upgrades we are going to do, and also what features we're going to turn on within Marlin so that we can get these printers all working with an extra level of safety. Now, having said that, one of the things I'm going to do with the Tronxy, just going through these really quickly, is with the Tronxy X5S, I'm going to try and take it up to 24 volts. I've got myself a 24 volt 15 amp power supply for it. I have a few extra heat beds, and one of the things I want to look at later is these are BuildTak ones from IGUS. for some special filaments that IGUS has, which is very slippery, so therefore very difficult to stick to a bed. The displays for controlling it, like I've already said, I've got some various Trinamics drivers that we're going to put in, and I'll show you how to configure those. I have a BL Touch equivalent. I got this from GearBest. It's called a 3D Touch, but from everything I can see, it's basically the exact same mechanically as a BL Touch. It's not the original, but it does seem to work. But I haven't tried these yet, so I'm still open to figuring out whether they're crappy or whether they're good. I don't know. 24-volt cartridge for a hot end when we upgrade one of the systems to 24 volts. I have a couple of external MOSFETs so that we can try and improve the heat bed temperatures that we're getting. And I have a silicone mat. Now this is a, I believe, 720 watts, 120 volt silicone heat mat, which I'm going to use for the printer that I started building last year. I'm going to be getting that one completed. I'm going to create a 300 by 300 bed, and I'm going to use that silicone heat mat to heat the bed. Now I'm going to try and make the bed compatible with the other printers so that if I choose to, I can move the aluminum base bed onto a different printer if I want. All right, so let's get to the computer and have a look at the settings that I've discovered. I will publish these on my website or make them available through Bitbucket or something so that you can download it and have a look for yourself. I've got a spreadsheet that lists all of the main parameters of Marlin on one sheet within it, and on the other sheet I've got the basic pins that are being used. Now what I'd like to actually hopefully happen is people will send me other configurations and I can just extend this spreadsheet and maybe have something that covers a lot more printers. I know that some of the basic well-known controllers are already in Marlin so that you can just pick the right board and away you go. But a lot of the Chinese 3D printers have, let's just call it compatible boards with weird names, and it's not always easy to figure out which board and how to program it. All right, because for instance, this Melty board, you have to load Sanguino drivers into the Arduino IDE before you can program it. And there is no bootloader on here either, so you have to program it through the ISP socket. And that probably goes for a lot of these other controllers too. So when we go through each of the boards, we're going to look at the specifics for it, how to program it, and what features we're going to turn on. And in some cases we're going to, once we've got them all up to the latest version of Marlin, then we're going to go back to each one and turn on things like BL Touch, put in the Trinamics drivers on a couple of them perhaps, so that we can get rid of some of the salmon skin artifacts and things, make them run a little quieter, etc. And then I think, so that's going to be three videos just doing these upgrades. I'll cover each one in a separate board to keep them short. We'll look at changing the controllers and what these options are. Both of these 32-bit controllers don't use Marlin. They use something else right now. Marlin is going through development to bring it up to full 32-bit compliance. I haven't tried any of the beta stuff yet to see if it works on these boards. But one of the things we probably will do for the Tronxy X5S is probably put in the Ramps 1.4 board that I have here. And when we do that, I will show you how to modify it for 24-volt operation and get rid of these fuses that are on here that really don't like to work at 24 volts. They'll actually fail. They're not designed for that higher voltage. And maybe put in either some inline fuses or some automotive fuses. Like there's a mod you can do that allows you to plug in an automotive type fuse instead. And then separately to all of that, we'll look at using the latest Raspberry Pi 3 Model B Plus to run Octoprint or something and be able to talk to these boards. So think that pretty much covers it, so let's get to the computer.